Hello, space enthusiasts and curious minds alike. Welcome back to our channel, where we dive deep into the mysteries of the cosmos. Today, we're venturing into the enigmatic atmosphere of Venus, our neighboring planet, to uncover a surprising clue that scientists have recently discovered about its past. Grab your space gear and let's get ready to explore the secrets Venus has been holding on to. Scientists have made a groundbreaking discovery in Venus's atmosphere, an unexpected surge in deuterium levels relative to hydrogen. While this may seem like a dry fact, the implications are nothing short of revolutionary, potentially challenging our entire view of this enigmatic planet. This finding suggests a radical shift in our perception of Venus, long considered merely a desolate and unwelcoming world. Here's why it matters. Venus has often been dubbed Earth's twin because of its comparable size, explained Hiraki Karyu, a researcher at Tohoku University and a key member of the study team. However, despite these physical similarities, Venus has followed a starkly different evolutionary path. Unlike Earth, with its relatively mild surface conditions, Venus presents a harsh, extreme environment. This discovery could dramatically reshape our understanding of Venus, prompting scientists to reconsider what we know about our closest planetary neighbor. The extreme conditions beneath Venus's dense cloud layers make it nearly impossible for liquid water to exist in any significant quantity. To give you an idea, the altitudes on Venus contain 150,000 times less water than similar altitudes on Earth, the scientists noted in their study. However, this may not have always been the case. Deuterium and hydrogen, while isotopes of the same element, differ in their atomic makeup. They have the same number of protons, but a different number of neutrons, giving them distinct atomic masses. Despite these differences, their chemical behaviors are remarkably similar. This subtlety in their composition leads to profound implications about Venus's past and its atmospheric mysteries. Isotopic ratios reveal much about our universe, similar to how carbon dating unveils the age of organic materials by comparing the isotopes carbon-12 and carbon-14. Over time, the carbon-14 decays, altering this ratio and providing a timeline of the material's age. Venus and Earth are thought to have started with similar HDO/H2O ratios, having both formed in a sweltering region of the early solar system where water was scarce. It's believed that both planets were later showered with water by ice-laden asteroids from the outer asteroid belt, leading to comparable initial deuterium to hydrogen D/H ratios. This theory is supported by the similar levels of volatile elements, such as carbon and nitrogen, found on both planets. However, data from the solar occultation in the infrared SOIR instrument on the Venus Express, operational from 2006 to 2014, reveals a twist in this narrative. Scientists discovered that the ratio of HDO to H2O in Venus's atmosphere is now 120 times higher than previously thought. This significant enrichment results from solar radiation breaking down water isotopologues in the upper atmosphere, creating separate hydrogen HA deuterium D atoms, noted the ESA scientists. Because hydrogen atoms escape into space more easily due to their lighter mass, the HDO/H2O ratio has steadily increased. Interestingly, they observed that the concentration of both water molecule types, H2O and HDO, escalates at altitudes between 70 and 110 kilometers, 43 and 68 miles above Venus's surface, reaching levels more than 1,500 times higher than in Earth's oceans. This suggests a profound difference in the atmospheric processes between the two planets. The team theorizes that these processes are influenced by climate mechanisms tied to sulfuric acid, H2SO4, aerosols, which dominate Venus's cloud composition. These aerosols originate just above the clouds, where temperatures fall below the sulfurated water dew point, resulting in the formation of deuterium-enriched aerosols, the scientists elaborated. These particles ascend to higher altitudes where the heat causes them to evaporate, releasing a higher fraction of HDO compared to H2O. The vapor then cycles back downward, perpetuating this dynamic process. How do these new findings reshape our understanding of Venus? First off, the research team believes that future studies need to meticulously account for how the ratio of deuterium to hydrogen, D/H, fluctuates with altitude when assessing the total volumes of these gases in Venus's atmosphere. The way the D/H ratio varies with height plays a crucial role in determining how quickly hydrogen and deuterium are lost to space. Interestingly, observations indicate that more deuterium is released high in the atmosphere than previously anticipated, which could significantly alter the overall D/H ratio if some of this deuterium escapes. This insight underscores a critical point: to fully grasp the evolution of Venus's atmosphere and quantify the water it may have lost over millennia, scientists must employ sophisticated models that consider these variations in altitude. This approach is key to unlocking the secrets of Venus's climatic past and its atmospheric dynamics. In a groundbreaking study, researchers have made an astonishing find in the thick, toxic clouds of Venus. This discovery revolves around certain chemical compounds that are not just mere constituents of the atmosphere, but are also storytellers of the planet's history. These compounds suggest that Venus might have been a very different place millions of years ago. Let's unpack what these chemicals are and how they were found. The key players in this discovery are rare isotopes and sulfur dioxide levels that tell a tale of water and volcanic activity. These isotopes indicate that Venus could have had substantial water reserves, possibly even oceans, before undergoing a catastrophic transformation. The presence of sulfur compounds adds a layer to this story, hinting at intense volcanic activities that could have reshaped its entire atmosphere. To arrive at these conclusions, scientists employed advanced spectroscopy and radar mapping techniques from orbiting satellites. These tools allowed them to peer through the opaque clouds of Venus and analyze the atmospheric composition without landing on the surface. This segment will explore the cutting-edge technology that made these observations possible. What does this mean for our understanding of Venus and potentially other celestial bodies? These findings challenge our previous notions about Venus as a static, hellish wasteland. The dynamic past suggested by these atmospheric clues opens up new discussions on planetary evolution and even the possibility of life. Given these exciting discoveries, several space agencies are already planning future missions to Venus. These missions aim to further study its atmosphere and surface, providing clearer insights and possibly even direct samples to analyze back on Earth. We'll discuss what's on the horizon for Venus exploration. One of the most striking features of Venus is its thick, dense atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid. This atmosphere creates an extreme greenhouse effect, trapping heat and raising surface temperatures to over 900 Fa, 475 CE. But why is Venus's atmosphere so different from Earth's despite the two planets being so similar in size? This segment explores the composition and behavior of Venus's atmosphere and its impact on the planet's surface conditions. Venus is often cited as a cautionary tale of what could happen to Earth with unchecked greenhouse gas emissions. The runaway greenhouse effect on Venus has turned it into a fiery, inhospitable world. We'll delve into how this process works on Venus, comparing it with Earth's greenhouse effect, and discuss what lessons we might learn about climate change here at home. Scientists believe that Venus may have once had oceans, similar to Earth. However, the planet is now bone dry. What happened to all the water? In this segment, we'll explore theories about how Venus lost its water, including the role of solar winds and the lack of a magnetic field to protect the atmosphere from being stripped away. Venus is home to thousands of volcanoes, some of which may still be active today. The planet's surface is dominated by vast lava plains and towering volcanoes. In this segment, we'll explore the volcanic history of Venus, how it might have contributed to the planet's atmospheric composition, and what ongoing volcanic activity could mean for future exploration. Unlike Earth, Venus has an extremely weak magnetic field. This segment will explore the implications of this weak magnetic field for the planet's atmosphere, particularly how it might have allowed solar winds to strip away water and other volatile compounds, leading to the dry, inhospitable world we see today. While Venus's atmosphere is a furnace of heat and pressure, its surface tells a story of intense geological activity. This segment will delve into the various landforms on Venus, including its vast lava plains, shield volcanoes, and deformed highlands. We'll also discuss the mysterious tesserae, regions of the planet that suggest complex geological processes. Venus has captivated humanity for millennia, both as a brilliant object in the sky and as a symbol in various cultures. In this segment, we'll take a break from the science to explore how Venus has been represented in mythology, literature, and popular culture. From the Roman goddess of love to Sisyphean depictions of a fiery hellscape, Venus has always held a special place in human imagination. The Soviet Union was the first to successfully land spacecraft on Venus. Their Venera missions in the 1960S and 70S provided the first close-up images and data from the surface of another planet. This segment will highlight the achievements of the Venera program, the challenges faced by these missions, and what they revealed about Venus. In the late 1970s, NASA launched the Pioneer Venus project, which included an orbiter and multiple probes to study the planet's atmosphere and surface. This segment will cover the key findings of this mission, including insights into the planet's atmospheric structure and the surprising discovery of lightning in Venus's atmosphere. NASA's Magellan spacecraft, launched in 1989, provided the most detailed maps of Venus's surface to date. Using radar to penetrate the thick clouds, Magellan revealed a world shaped by volcanic and tectonic forces. In this segment, we'll discuss the Magellan mission's findings and how they have deepened our understanding of Venus's geology. Launched by the European Space Agency in 2005, the Venus Express orbiter spent 8 years studying Venus's atmosphere, weather patterns, and surface characteristics. This segment will explore the key discoveries made by Venus Express, including the detection of mysterious dark streaks in the atmosphere that some scientists speculate could be evidence of microbial life. Japan's Akatsuki mission, also known as the Venus Climate Orbiter, has been studying Venus since 2015. This segment will cover Akatsuki's mission objectives, including its investigation of Venus's weather and atmospheric dynamics, and how its findings are contributing to our broader understanding of the planet. In 2020, scientists made headlines with the potential detection of phosphine in Venus's atmosphere, a gas that, on Earth, is associated with microbial life. This segment will delve into the debate over this finding, the challenges of confirming it, and what it could mean for the search for life beyond Earth. How did Venus form, and why did it evolve so differently from Earth? In this segment, we'll explore theories about Venus's formation and early history, including the possibility that it once had conditions more favorable to life. We'll also discuss how these theories inform our understanding of the solar system's development. Studying Venus provides valuable insights into the nature of exoplanets, planets orbiting other stars. This segment will explore how our understanding of Venus helps scientists predict what conditions might be like on distant exoplanets, especially those in the so-called Venus zone, where planets might experience runaway greenhouse effects similar to Venus. With renewed interest in Venus, the planet is becoming a focal point for future space missions. This segment will discuss upcoming missions, including NASA's VERI, TASNDAV, INC-I+ missions, as well as the European Space Agency's Envision mission, all aimed at unlocking more of Venus's secrets. Exploring Venus is no easy task. The planet's extreme temperatures, crushing atmospheric pressure, and corrosive clouds present significant challenges for spacecraft. In this segment, we'll discuss the technical hurdles of Venus exploration and how engineers are designing new technologies to overcome them. The idea of terraforming Venus, transforming it into a more Earth-like environment, has been a topic of science fiction for decades. But could it ever be possible? This segment will explore the theoretical possibilities and enormous challenges of terraforming Venus, from reducing its atmospheric pressure to cooling its surface. Venus and Earth are often called sister planets because of their similar size and composition. However, their evolutionary paths have been drastically different. This segment will compare and contrast the two planets, exploring how studying Venus can help us better understand Earth's past, present, and future. While Mars is the current target for human exploration, some scientists have proposed sending crewed missions to Venus. This segment will explore the concept of aerostat missions, where humans could live and work in the upper atmosphere of Venus, where conditions are more Earth-like. Venus's runaway greenhouse effect offers a stark warning for Earth's climate future. This segment will explore how studying Venus's climate can provide insights into the potential long-term consequences of climate change on Earth and the importance of addressing greenhouse gas emissions. Venus plays a unique role in the field of astrobiology, the study of life in the universe. This segment will explore how Venus challenges our understanding of habitability and what it might teach us about the potential for life on other worlds, particularly in harsh environments. Studying Venus not only helps us understand the planet itself, but also provides clues about the early solar system. This segment will delve into how Venus's history might mirror the early conditions of other planets, including Earth, and what this means for our understanding of planetary evolution. Venus's interaction with the solar wind offers valuable insights into space weather, which can affect spacecraft and satellites in our solar system. This segment will discuss how studying Venus helps scientists better understand space weather phenomena and protect space assets. Venus has been a popular setting in science fiction for decades. From early depictions of Venus as a lush jungle world to modern portrayals of it as a toxic wasteland, this segment will explore how Venus has inspired writers, filmmakers, and game designers. We'll discuss how these depictions have evolved with our growing understanding of the planet. While Mars and Europa often take center stage in the search for extraterrestrial life, Venus is now being reconsidered as a candidate, particularly in its upper atmosphere, where temperatures and pressures are less extreme. This segment will explore the potential for life in Venus's atmosphere, what it would mean for our understanding of life in the universe, and how future missions might search for it. Citizen science is becoming increasingly important in planetary research, and Venus is no exception. This segment will highlight how amateur astronomers and citizen scientists are contributing to Venus research, from analyzing data to identifying atmospheric phenomena and how you can get involved. Though Venus is millions of miles away, studying its weather systems can offer insights into Earth's own meteorological phenomena. This segment will explore the connections between Venusian and terrestrial weather patterns, including how understanding Venus's extreme winds and cloud formations could improve our climate models on Earth. Mars often overshadows Venus in planetary exploration, but both planets offer valuable insights into planetary evolution and the potential for life. This segment will compare the two worlds, examining why Mars has been the focus of exploration and how Venus presents a different set of challenges and opportunities for scientists. Exploring Venus, especially with crewed missions, would pose not only technical but also psychological challenges. The extreme conditions and isolation of a mission to Venus could take a toll on astronauts' mental health. This segment will discuss these potential psychological challenges and how space agencies might prepare astronauts for such a mission. During the early days of the space race, both the United States and the Soviet Union targeted Venus with some of their first interplanetary probes. This segment will delve into the role Venus played in the Cold War space race, the competition to explore its mysteries, and how these early missions shaped the future of planetary science. Venus offers a natural laboratory for studying extreme conditions that are difficult to replicate on Earth. From its high-pressure atmosphere to its scorching surface, this segment will explore how scientists use Venus to study phenomena such as supercritical fluids, acid rain, and extreme wind dynamics, and what these studies can teach us. Our understanding of Venus has changed dramatically over the past century. This segment will trace the evolution of our knowledge, from early telescope observations that led to misconceptions about the planet, to the detailed data we've gathered from modern spacecraft. We'll highlight the key discoveries that have transformed Venus from an object of speculation to a subject of serious scientific inquiry. As we discover more exoplanets, many of them are found to have environments similar to Venus. This segment will discuss how Venus serves as a template for understanding the climates of these exoplanets, particularly those close to their stars, and how this knowledge can help us identify planets that might be habitable. Landing on Venus is far more difficult than landing on Mars or the Moon due to its extreme conditions. This segment will delve into the specific challenges faced by landers, including surviving the descent through thick clouds, enduring the intense heat and pressure on the surface, and the short operational lifetimes of past mission. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.